Hi everyone, welcome to our physics class. In the previous class, we have studied about moving coil galvanometer, principle, construction, working and theory. So in this class, we are going to discuss about how do you convert a galvanometer into ammeter and how do you convert a galvanometer into voltmeter. So this is moving charges and magnetism part 9. Okay, well, let's start today's class. So conversion of galvanometer into ammeter. So a galvanometer can be converted into ammeter by connecting a very small resistance that is called shunt. By connecting a very small resistance that is called shunt that must be connected in parallel with the galvanometer. So what is the meaning of shunt? Shunt is a very small resistance that must be connected in parallel with the galvanometer. So then the galvanometer is converted into ammeter. Okay, so a galvanometer can be converted into ammeter by connecting a very small resistance that is called shunt that must be connected in parallel with the galvanometer. Actually, shunt increases the range of the converted ammeter. Shunt protect the galvanometer from getting damaged. Okay, shunt increases the range of the galvanometer and shunt protect the galvanometer. So that is the use of the shunt. So how do you convert galvanometer into ammeter? A galvanometer can be converted into ammeter by connecting a very small resistance that is called shunt that must be connected in parallel with the galvanometer. Then the galvanometer is converted into ammeter. So here we have to calculate the value of shunt. Okay, so this is I is the main current that is flowing through this circuit. So A is a junction. So at this junction, current is splits into two parts. Okay, so one is Ig and another one. Let us consider this one as Is. Is is the current flowing through the shunt. So Ig is current flowing through the galvanometer. Then galvanometer shows the full scale deflection. So according to Kirchhoff's current law, the sum of currents entering the junction is equal to the sum of currents leaving the junction. Is it not? So here the main current I is equal to Is plus Ig. Okay. So main current is equal to Is plus Ig. That means the sum of current entering the junction that is equal to sum of currents leaving the junction. And what is the value of Is? Is is equal to I minus Ig. Is is equal to I minus Ig. So call this as equation number 1. So actually here shunt and galvanometer both are connected in parallel. So then the potential difference across the shunt that is equal to the potential difference across the galvanometer. According to Ohm's law, V is equal to the product of current and resistance. So the potential difference across the shunt is current flowing through the shunt into the resistance of the shunt, Is into S. That is equal to potential difference across the galvanometer is the current flowing through the galvanometer into the galvanometer resistance. So S is equal to IgG divided by Is. S is equal to Ig into G divided by Is is I minus Ig. So this is the mathematical expression for the shunt. S is equal to IgG divided by I minus Ig. So how do you convert a galvanometer into ammeter? A galvanometer can be converted into ammeter by connecting a very small resistance called shunt that must be connected in parallel with the galvanometer. Then the galvanometer is converted into ammeter. So what are the uses of shunt? Shunt must be connected in parallel with galvanometer. So then shunt converts the galvanometer into ammeter. Shunt increases the range of ammeter. Shunt protect the galvanometer. So those are the uses of shunt. Okay, shunt converts the galvanometer into ammeter. Shunt protect the galvanometer. Shunt increases the range of ammeter. So what is the meaning of shunt? Shunt is a very low resistance. Shunt is a very low resistance that must be connected in parallel with the galvanometer. Then galvanometer is converted into ammeter. So what is the effective resistance of this converted ammeter? So that is very important. So effective resistance across AB. So that is equal to. So actually here two resistors are connected in parallel. So if two resistors are connected in parallel, so what is the effective resistance? The equivalent resistance, reciprocal of equivalent resistance is equal to sum of the reciprocals of individual resistances, right? So here the effective resistance of ammeter is 1 divided by RAB, that is equal to 1 by G plus 1 by S. So GS is the LCM, S plus G. So this is 1 divided by RAB. So RAB is equal to GS divided by S plus G. Okay. So this is the effective resistance of converted ammeter. So how do you convert galvanometer into ammeter? By connecting a very small resistance that is called shunt that must be connected in parallel with the galvanometer. So what is the meaning of ammeter? Ammeter is an instrument used to measure current flowing in a circuit. And the resistance of ammeter, ideal ammeter. So this is very important point. Resistance of ideal ammeter. Resistance of ideal ammeter is 0. Usually ammeter having very small resistance. So resistance of ideal ammeter is 0. And ammeter is always connected in series. So how do you connect ammeter in a circuit? So that is very important. Ammeter is always connected in series with the circuit. If it is connected in parallel, it will draw the maximum amount of current and the needle of ammeter will get damaged. That is why ammeter is always connected in series with a circuit. Okay, so this is about the conversion of galvanometer into ammeter. So the next topic is conversion of galvanometer into voltmeter. So a galvanometer that can be converted into voltmeter by connecting a very high resistance that must be connected in series with the galvanometer. A galvanometer can be converted into voltmeter by connecting a very high resistance that must be connected in series with the galvanometer. Then the galvanometer is converted into voltmeter. Okay, so here actually the galvanometer resistance that is connected in series with high resistance. So the net potential difference across this combination is equal to the potential difference across the galvanometer plus the potential difference across high resistance. So according to Ohm's law, the potential difference across galvanometer is IgG, and potential difference across the high resistance is Ig into R. So here Ig is taken as common, so we get R plus G. So V by Ig is equal to R plus G. So R is equal to V divided by Ig minus G. So this is the value of high resistance. R is equal to V by Ig minus G. Okay. So a galvanometer can be converted into a voltmeter by connecting a very high resistance in series with the galvanometer. Okay, so then the galvanometer is converted into voltmeter. So voltmeter is always connected in parallel across any branch of the circuit across which the potential difference is to be measured. The voltmeter is always connected in parallel. Ammeter is always connected in series with the circuit. Voltmeter is connected in parallel across any branch of the circuit across which the potential difference is to be measured. So usually the resistance of voltmeter is maximum. The effective resistance of voltmeter is maximum. So that is the effective resistance of the converted voltmeter is R plus G. Two resistors are connected in series. What is the formula? Rs is equal to R1 plus R2. So here R1 is G, R1 is R, R2 is G. So the effective resistance is R plus G. So this is the effective resistance of the converted voltmeter. Okay, so voltmeter is always connected in parallel across any branch of the circuit. So what is the resistance of ideal ohmmeter? So this is very important. Resistance of ideal voltmeter. Resistance of ideal voltmeter, that is infinity. Resistance of ideal ammeter is 0. Resistance of ideal voltmeter, so that is infinity. So how do you convert galvanometer into voltmeter? By connecting very high resistance in series with the voltmeter. Okay, after that, let us discuss about what are the main differences between ammeter and the voltmeter. So ammeter is an instrument used to measure the current flowing in a circuit. So voltmeter, that is an instrument used to measure the potential difference across any branch of the circuit. So ammeter is always connected in series. The voltmeter is always connected in parallel across any branch of the circuit. So ammeter is essentially a low resistance galvanometer. Voltmeter is essentially a very high resistance galvanometer. It is a low resistance galvanometer. It is a very high resistance galvanometer. And a galvanometer can be converted into ammeter by connecting a low resistance in uh, parallel, with the galvanometer. So galvanometer can be converted into voltmeter by connecting a very high resistance in series with the galvanometer, and the resistance of ideal ammeter is zero. The resistance of ideal voltmeter is infinite. So what are the differences between ammeter and voltmeter? It is used to measure current flowing in a circuit. It is used to measure potential difference across any branch of the circuit. The ammeter is always connected in series. Voltmeter is always connected in parallel across any branch of the circuit. So it is essentially low resistance galvanometer. It is essentially very high resistance galvanometer. So the resistance of ideal ammeter is zero. Resistance of ideal voltmeter is infinity. So a galvanometer can be converted into ammeter by connecting a very small resistance called shunt that must be connected in parallel with the galvanometer. So a galvanometer can be converted into voltmeter by connecting very high resistance in series with the galvanometer. Okay, thank you.